Quick background on Matrix: we started in the mining space. Started working with proximity detection around 2009 in the underground mining space. Kind of grew up from there. We launched an electromagnetic version of proximity detection. Had some decent success on the mining side, and then decided to come up to the surface around 2017, 2018. That's when we first started designing collision avoidance AI camera systems. So had our first version that was targeted at surface mining, looking at larger haul trucks. Found that version had some good applications in fork trucks, and then expanded to V2, the Vision AI platform, which released late last year. So we've got a decent amount of history over the past 15 years working around collision avoidance. See some new faces out there. Quick introductions for us. My name is Brian Jones. I'm VP of Sales and Marketing for Matrix. This is Derrick Bennett. He's a product manager for OmniPro, our collision avoidance system. We're going to kind of walk you guys through how we think about implementations, some of the different technologies. General objective here is to give you guys a good understanding of the current collision warning, collision avoidance landscape, where we think the market might be heading, some technologies that are involved in that landscape, and then look at a framework for making a decision on what technology you might want to go with, or at least how to evaluate those technologies. So the why is pretty obvious, but everybody kind of wants to run through stats real quick. We threw some up here from the National Safety Council, but I won't really walk through those with you. You can read those. General idea is you're probably here because you're either a tech person that is interested in new technologies and implementations, or you've identified a risk at one of your operations that you're wanting to try to mitigate with one of these types of systems, and you're thinking, how do I go about doing that? So here's the why. Generalized, we want to keep our people safe. We want to give them a safe working environment, and that's kind of our mission. So again, kind of stepping through what we're going to talk about today, we'll go through some engineering controls, so what some of the operations may be doing right now, how we think about implementing collision avoidance technologies, and how those fit into engineering controls, and then as you can kind of see around here, some automations that would be the next step. Again, we'll go through some of the technologies. We'll talk about some market status, where we think those technologies are moving towards, and then we'll get into the evaluations. We'll have notes, we'll have these presentations available. As we kind of step through this, be thinking about your particular operation, how you would apply these different technologies, or how you would think about solving problems, to give it a little bit of context for the presentation. So thinking about engineering controls, what we're doing, and we want to put this in the context of collision warning, collision avoidance. The PP and administrative controls, that's realistically what you're doing right now. So you're thinking about tape lines and reflective and bollards and how you lay out your operations and those types of things. Those are what we think of as PP administrative controls, and it starts to get into engineering. But when you have lights, the little blue lights that are out on the floors right now, and you have your horns that you've had for a long time, those are the initial stages of alerting people that are machines around them. What we're really trying to get into in this engineering controls piece is collision warning. That's the first real step. And so collision warning is defined by alerting the operator that someone's in a general area where they shouldn't be. You then move into collision avoidance, which is actually taking action with the machine around an intended target. Not target, that's a bad way to say that, an intended object that's in a zone that you don't want them to be in. So you're slowing down, you're averting that incident. There's a number of technologies that we'll talk about here in a minute that do both of those, either by themselves or integrated with another system. When you think about sensor fusion, that's still in some of that engineering controls, may get up into substitution, but you're looking at some of these platforms you see out here where they're melding 2 or 3 different technologies together to perform either a different function or to do a different task. And so whether that's collision avoidance or it's picking up a box or doing something along those lines, that's the next evolution of collision avoidance systems is moving into sensor fusion. You can have another ground truth you're thinking about, whether you have a camera AI system that you add a radar solution to do different things. But that's the kind of fusion we're thinking about as we think about engineering controls. And then you move into automation. You've got a lot of options around here that you can see machines running by themselves. Think about routing and navigating through space and planning ahead of time. That's probably the next phase that gets into the elimination section. So we'll go ahead and dive straight into the technology piece. That's where we really want to concentrate some of our time. When we think about technology in the market, we think about two different groups, for lack of a better word. There's the group that has a personal wearable device, and then there's the group that doesn't require a personal wearable device. We segment those for two different reasons. We've got a lot of experience, like I said, with electromagnetics over the past 10 to 15 years that requires a personal wearable device, but we do that for a reason. It's fit for purpose in an underground operation. We can gate that underground operation. So we know who's going underground, we know where they're going to be in general, and you can make sure that they have a tag before they go underground. If you have an operation that you can gate, great. You should look into these types of solutions. If you can't gate that operation, and there can be administrative people or other visitors that are coming into the operation, and they don't have a tag on, you have an inherent risk, and maybe look at one of these other types of technologies. So I'll start from the bottom up. What's life without a little excitement? Electromagnetics, like I said, we've had a lot of experience with. That's very good at seeing through rock, seeing through walls, doing a lot of that type of thing. When you get into environments where you have racks and a lot of metal, you're just going to start seeing some issues. You're going to start seeing interference. So it's very good for certain specific applications. It's not an inexpensive solution, but you can use that for a specific purpose depending on what your issues are at your operation. Again, if you're inside of a large warehouse with racks, that's going to be a challenge. If you're outdoors, maybe there is a specific solution where you could use this. GPS and ultra-wideband, I kind of talk about those in similar aspects for a reason. GPS is great. There's been a lot of development on the GPS side over the past few years. You've got 6 years ago, widely available GPS might have had an accuracy of 3 meters to be able to use for collision avoidance applications. Now it's down to probably about a foot. There's a lot of things you can do with GPS around routing outside, cycle timings, that type of thing. The biggest challenge with GPS is it doesn't work inside. So if you're outside running in an operation, you move a fork truck inside or move a loader or anything else inside, you're going to have an inherent risk if you only have a GPS solution. On the contrary, with ultra-wideband and RF systems in general, there's two different ways those work. Either you have an infrastructure that is put throughout your facility, and that acts a lot like a GPS system, where it's triangulating a specific asset running around that facility. Those are great if you want to track just inside of a facility. It can be costly with the infrastructure, but there's a lot of other things you can do with those around, again, routing, cycle timing, tracking assets, those types of things. The biggest challenge, again, is if you have an infrastructure inside of that facility and you go outside, you immediately have a risk from the collision avoidance perspective of not being able to detect around that machine. There's also RF on-vehicle-based systems. It's actually not mentioned on here, where they create a small bubble, what we call a round zone around a piece of equipment, transmit RF to a personal wearable device or a tag. Those are inexpensive, good ways to get a system on a machine if you're looking to check a box. The biggest challenge there is those bubbles aren't discriminate. So if you want further distance in the front, you're going to have further distance on the sides. Those inherently have false detections or nuisance alarms when you're actually passing at a safe distance. So thinking a big bubble around that, it makes it a little bit difficult to implement in tight space. So kind of moving up to the no tag setup, I kind of group these not perfectly in line here, but thinking about radar and ultrasonic, I somewhat group those together. Both of those are, we call them basic systems. Ultrasonic is what you have on the back of your cars in most cases. That's going to provide a backup alarm at close distance. It's a relatively inexpensive solution, but it's indiscriminate. You're not detecting a specific item. You're detecting anything around that machine. Similarly with radar, that has a little bit further distance, and it can detect individual objects in space, but it can't detect a specific thing. You're always going to be detecting anything that's around you. That becomes an issue when you're working in tight space. You have a lot of nuisance alarms that may pop up that you didn't really want to have come online. That's going to drive your operators crazy. They're going to have some issues. They'll likely start reaching to unplug that alarm at some point. The next two that we might touch on, the LiDAR and time-of-flight systems. They're both very similar in that they can give you ranging. So on the ranging side, they have what's called a point cloud that will give you some distance away from a machine. Issues with time-of-flight is those are both very good systems. Time-of-flight, you have some challenges with distance. And there's also crosstalk between two systems. So if two fork trucks are running up on each other, there's two time-of-flight sensors on both those trucks, there can be some interference between those two. But again, they do a great job of providing range at close-in distances. LiDAR, there's been a lot of advances in the LiDAR space. You can get very accurate readings at very far distances. They use those a lot with some of these machines you're seeing around here on automation. They use them with driverless cars. Fortunately or unfortunately, it's an expensive solution still at this point. That technology will hopefully come down in price and be available for fork truck applications. Right now, it's just still a little bit expensive. There are some issues with some environmental effects there as well. It needs to be calibrated, but technology's come a long way there, and it'll be a good solution for across your fleet, hopefully in the coming years. The two we left here are infrared cameras and AI cameras. We've got a lot of experience with AI cameras. I'll leave that one to last. On the infrared side, you have those are really good at detecting in low light. So if you have applications where you're running at night and for whatever reason you don't have a lot of light, you want to detect around a certain area, that's a very good solution. It can detect human form. It can detect some other things if you want to train an AI model to do that. But they do have to be calibrated on a regular basis. They're not inexpensive. But if you have an application that is a low light application, those are great solutions to look into. When we came to the surface and started working on developing an AI cameras, developing a collision avoidance system for the surface, we went through all of these different technologies. We've either been experienced in testing or implementing some of these technologies in some of our product lines, or we've tested the majority of them. We ended up landing on AI cameras. They are inexpensive to implement. They can detect an intended object. You can train a model to detect many different types of intended objects, from people to fork trucks to haul trucks to signage and throughout. Some of the challenges you're going to have there, it does take a while to train those models, get them up and going. You also have to consider nighttime operations. You're going to have lighting around those cameras. And for heavy, dense fog, you might not be able to get the distance you could get with some of these other technologies. There are downsides and positives to all of these. So when we think about the next steps, where we're going from here, there's likely layers of technology that are implemented to provide a final solution for different risks inside of an operation. So, for example, you see these little units running around over here that are picking up boxes. They all have LiDAR, they likely have radar and ultrasonic sitting on top of them. That is what we define as sensor fusion. We looked at similar things, providing close-in distances and cameras for long distances. If you think about the driverless cars you see driving, we were in Phoenix last week. There's a lot of driverless cars called Waymo that are driving around town. They have ultrasonics, radar, cameras, and I think there's one more technology they have layered in to do both long distance side detection and some parking assistance. So they go to the next step, which is controlling the vehicle, which is the automation piece we talked about. But that's what we think about when we talk about sensor fusion, is how do you layer on different technologies to provide different functionality or address different risks in operations. The last piece kind of mentioned here, when you're looking at implementing technologies, you want to make sure that you can, that the technology advances rapidly. So what we had a year or two ago versus what we have right now versus what we're going to have in 3 years is dramatically different. You're going to want to implement a solution that has the ability to scale and to change out your sensor sets, advance your sensor sets, have a model that works well to do that, and working with a company that's willing to do that with you. That hits most of that one. So thinking about how do you actually implement these different systems? We have two different types of considerations. One I have is administrative. The other is going to be evaluative. So thinking about how do you actually put together a pilot or test these systems. We'll start off with the admin side. I heard a phrase not too long ago that kind of stuck with me. It's said a problem well defined is a problem half solved. And so general idea is if you can define the problem you're having or the risk you have well enough, then you got the thing half solved. And that kind of rings true here as well, thinking about the different technologies you can evaluate. If you can define the problem, the area, the environment, the rate at which the problem is having, who's actually having the problem, what truck it's actually occurring on, if you can define that well enough, the implementation is going to be simple and easy, the evaluation is going to be even easier. So there's probably three things on the administrative side to think about. Working within a budget, internal buy-in, and production impact. So working within a budget, with enough time and money, you can do anything, right? We all don't always have that luxury. So when you're looking at the administrative side, think about what can I do right now versus what I can do 6 months from now versus what I can do next year. What can I do with the trucks that are currently in my operation? What trucks am I rolling out within 6 months that are older? What new trucks are coming in? Where do I see my risks? Is it on lift trucks, pickers? Is it on a loader that's outside? Whatever that is. Think about where my largest risks are right now and how do I address those sooner than later, and then to the next point, who actually has to buy in on that project. So over the past few months, we've started to understand the different groups inside of organizations that need to buy into these projects. You've got anywhere from IT to management to production to safety to your C-suite and whoever else needs to sign off on projects. Start bringing them in sooner than later. We've seen some of these move through pilots and get to certain stakeholders that aren't interested in moving forward, and they can kill your project. So think about how you address those up front, bring stakeholders in sooner than later, and then assign a champion inside of your organization. So somebody that can stick with this from the beginning to the end, someone that has a general understanding of technology, can work in software, can understand what they're evaluating, in general, understand the risks, and then on top of that, the cost of inaction, staying at the status quo. If they're interested in just looking at new tech, that's great, but they also need to have an incentive to move that thing forward and be able to evaluate different technologies. They are going to have a lot of time in this, so assume they're going to live in this from inception all the way through to completion, and then solicit for internal feedback. You're going to have operators that are going to have a lot of opinions, and we've seen that throughout our rollouts. Make sure that you're taking those in and feeding those back to your vendors. On the production impact, nobody likes to talk about this, but there always will be a production impact when you start implementing new systems. You have change. It may just be in the pilots or the trials of new systems, but there will be slowdowns, whether you have to pull trucks offline to do installs, or whether you have some configuring and to do on the back end where you're tailoring zones to fit your operation. There will be slowdowns. Try to understand what impact that's going to have, what you're willing to withstand, and try to bring stakeholders in to understand that on the front end to where they're not chewing at your throat if you're slowing down production side. So we'll spend a little bit of time here on the evaluation side. This is one of the takeaways that we really wanted to focus on. Again, defining the problem. I put that in there twice because I think it's really important. Here you're on the evaluation piece, we're thinking about how we actually look at evaluating different technologies for implementation, and we're going to give you our experience. Hopefully that kicks you off on the right track. On defining the problem here, it's not the administrative side. You're actually looking at the rates of occurrence on your issues, what time of day are they happening, what machines are involved, again, where are they actually happening in space or in your operations, and then convert those into trial specs. So we've had a number of different pilots we've implemented or moving into rollouts where we've done the pilot in one area of the plant and the problem's actually happening maybe in another area of the plant. You want to localize that trial to both the operators and the types of machines that you're running and the area of the plant where you're having issues. We've done it across organizations where one operation may be entirely different, they're vertically integrated. One operation may be entirely different than another, and you're looking at maybe one technology doesn't work as well at these other operations. So think about the specifics of that environment. Talk to your vendors. So if you're looking at different technologies, and we encourage you to try different technologies. Talk to your vendors about what problems how they've solved the problem in your specific environment. Make sure they have a solution, make sure they've done it before. It's tough to be the guinea pig every once in a while. And then if they have reference sites, by all means ask them to go visit some of those reference sites. It's probably a good step there. Technology, explore your options, like I mentioned. You want a lot of different technologies will function to solve the same types of problems. So look at trialing and testing different types of technologies. Look at different vendors inside of those technology sets. You don't want to make an investment inside of these technology spaces that A, doesn't scale, doesn't evolve, and that you're going to end up losing your investment on. 5 years down the road, you want to make sure that thing can be iterated and moved forward, not just standing still at technology that was 5 years old. These things are going to advance rapidly. There's going to be, again, additional sensors that are layered on top of your current existing solution. So look at those different types of technologies. Again, this is a great place to do that. You have the majority of our competitors, other technology providers are going to be here this week. Encourage you to make sure you hit all of them. This is a good place to get a general understanding of a lot of those different technologies and how they might be able to fit with your current applications. The different components. That's another piece that we think is relatively important. Coming from the mining space, we had to build things that were very rugged. The general saying is a miner can break an anvil. So we try to develop things that will survive industrial spaces. You want those components that you put on that machine to be rugged. You want them, if they get smacked, you don't want them to break in half. They don't want to be some cheap little thing that's coming out of nowhere. You want those to be specific to your environment or have ratings for your environment. If you're running outdoors all the time, you're probably going to need an IP rating of some sort. If you're running indoors in dusty, tight environments, you're going to need something that's dust rated. Think about how the technology fits into the environment and what those components need to look like, and then make sure they're replaceable. So if you go and smack a camera, for example, off the side of a fork truck, make sure that thing is plug and play and you can replace it and get back to operations. You don't want your trucks being down for a long period of time just because a component got knocked off of it. Generally in functionality, there's some basic functionality you want to see in each one of these systems. There's alerting, there's alarming, there's integration with slowdown. One of the biggest pieces that we see a lot of people ask for is the ability to control a machine. Make sure that if that's something that you want to do, that you want to be able to remove throttle from a machine, that the system has the ability to do that. There's basic reporting and cloud platforms that you're going to want to understand. You're going to want to be able to get data off that machine. But all that being said, there's a lot of bells and whistles you can add to these systems that we've seen added into these systems. The functionality the system has to work to address the risk. So it can do all the nice bells and whistles in the world, but if it doesn't actually slow down, detect a person, detect a machine, address the risk that you're bringing it in to do, the bells and whistles don't mean anything. It has to perform its functionality well in production, or else it doesn't matter. That kind of leads into the next conversation around performance. There's always going to be a trade-off not a trade-off, but there's always a conversation around safety versus production. We've had it for 15 years between the mining space and the industrial space. You want to ensure that these systems are tuned to your operation. We go to great lengths to ensure that happens. You're thinking about how you install the system, the different areas in which you're operating with these systems, how they're interacting with other fork trucks or with people, how long those zones need to be out, what point do you want to start slowing down, how fast do you want to slow down, so that doesn't negatively impact production in the long term. Like I said, you're probably going to have some impact up front. That's going to happen. But long term, you want that to be tailored to run without any slowing to your operations, your production. I know there are some thin margins out there. You want to still be able to implement safety without having any impact there. So look at providers, look at vendors that are able to customize their products to fit your operation. That's something you're going to want to consider. A couple more things here. Benchmarking. So there's a whole bunch of benchmarks in industry. It's not all in the fork truck space. You've got some from automotive. You've got other sensor sets that have benchmarks in the world. For AI cameras, for example, you've got false positives and false negatives, which are the worst. You have true positives and true negatives. One of the indices we use is called an F1 score. It's a ratio that's performance ratio to. Derrick's going to kill me because I always mess this up. It's an indication of performance of the system that takes a number of those other metrics into consideration. So typically vendors can usually help you with those on benchmarking side, understand that you're testing apples to apples and you're actually getting the best product in its class for your operations. So quickly on testing and feedback, we talked about this a little bit already, but getting buy-in from operators is key. When we perform tests, we want to try to use the same operators over and over and over again. What you don't want to do is perform a test where that truck is being used by 3 or 4 different operators and continuously have to retrain those operators and then go back and you're getting subjective input from a lot of different people. You want to try to put it on 3 trucks. If it's 3 trucks in 3 different areas, that's great. But you want to try to use similar operators that are bought in to the product line and to change to solicit feedback from. Those are going to be your best input on whether the system's operating properly or if they're seeing a lot of issues. If you have production data on how production may be impact, or if over 30, 60 days, however long you're doing pilots for, that would be very useful. And then set objective and subjective evaluation criteria. So your subjective, think about how your operator feedback, but then run the objective tests on repeatability of zones, slowdown module, how the slowdown actually functions, how it works in passing different fork trucks, how it works in space, those types of things. You have to set objective goals to make sure that you're evaluating technologies one against the other in the same fashion. Price is always a conversation. There are a lot of pricey technologies out there that probably cost more than a fork truck if it's used. you can put those on your truck, but it's we don't see a lot of interest in that. People are, from our viewpoint, looking for a cost-effective technology to protect people, pedestrians, around a fork truck. The opposite of that is also true. You can go and find very inexpensive technologies to put on a fork truck that we've seen over time get replaced. You want to put something on that isn't going to break, that's going to be able to be supported, that's going to be advanced, not just check a box. Every time we've seen somebody check a box, they end up coming back later and looking for a longer-term solution that can give them the information they need. So consider that. Everybody has different budgets, but probably not good to go on the top or the bottom end of those. Integrations is another thing you really want to think about. The market's evolving. Collision avoidance is relatively new. There are going to be further integrations that come in the future. But what you want to think about right now is solving the problem that you have at your operations right now. So think about integrating with the existing fleet. If you want to provide a slowdown functionality, the systems need to be able to integrate with a slowdown module or someone that does that if they don't have their own. Think about how those set up on your existing fleet versus 5 years down the way. At some point, consider there will be OEM integrations, and there will likely be third-party integrations with, call it your telemetry system or your impact system or your production system or your routing system or whatever that is. You want to find a solution that has the ability to do all of those things so that you can outfit your existing fleet right now and you can future-proof yourself for outfitting your fleet in the future. Whenever new trucks come in, you're not going to have to worry about going and finding XYZ new system. That system can actually be evolved over time, which kind of jumps into the next one on the development. Ensure that the vendor you decide to go with has an ongoing development plan and ask them about that. Did they have a history of providing products to the market, iterating on those products and moving them forward? Had they brought the products to market in your industry? And is there things that you've seen them do before, or can they provide references to do that? Do they have an opinion on where technology is going? Because if they don't, they're probably not thinking about it. Ask the questions of the vendors of where they're going next so that you can future-proof yourself and not get hung up with old technology. Finally, the last one is probably the most important that we've seen is support. You can implement these things, you can roll them out, they're going to change. And if you don't have the support on the back end with experienced and knowledgeable people to help you move the product forward or to tailor the product to your environment, you're going to have issues. None of these systems work out of the box. They all have to be tailored for an environment. And frankly, you want that inside of your operations. You want somebody that comes in and says, all right, I'm going to do this for you and make sure that you're not losing out on production hours because a system's down or it's flagging false alerts or the operator wants to rip it off because it's driving them crazy. You want to consider who's helping you and who's helping you do those installs and that configuration and setting it up for your operations. So I think I'm slowly running out of time, but jump right into the takeaways. Hopefully we still have some time for questions after this. So thinking about the problem plus the environment equals the solution, and that's thinking, what is my exact risk inside of my operation? Can I find a technology that fits the environment that I'm working in that'll get me toward a solution? That's about it. And then set relevant evaluation criteria. So have a champion inside of your organization. Set benchmarks for evaluation on those. Consider how that tech is going to impact production. And then trial multiple solutions. Again, we're one provider of a dozen out there that provide different technology into the industry. We encourage you to try them all out, at least whatever would fit inside your organization. Again, discuss future development. Technology evolves quickly. If you're not thinking about the future, you're going to get left behind, and prioritize functionality. So make sure that system does the job that you're putting it on there to do. All the bells and whistles can come later, but it's got to be able to either slow down or stop or alert the operator when that intended object is in a risk area. If it doesn't do that core functionality, you're going to be upset with the purchase. Lastly, support. Again, if the vendor isn't prioritizing support and ensuring that these things are rolled out properly, you're going to be upset on the back end. And I think that ran me through time. So, if you guys have any questions, I think we have about 7-8 minutes left. We can run through some questions. Happy to answer those. Derrick is probably going to be able to answer those better than I can. Or we're right around the corner in C. If you guys don't want to ask questions now, we're happy to have conversations either here or afterwards. Pretty easy on me. All right. That's all we got for you. Appreciate you coming out.